Hi, my name is Gabe Oestreicher, and today I'll be presenting on the Oracle Big Data Toolset with a particular focus on the Oracle NoSQL Database. So, I imagine nearly everyone here has heard of Oracle and knows that they're a huge player in the database world. I don't think it's going too far to say that they've been the industry leader for decades. But the Oracle database, and the relational database model in general, is all about getting everything in its place and having a highly structured and fairly static architecture. This comes with a lot of overhead. The payoff is that for medium to large data sets with a structure that doesn't change much, the performance is exceptional. However, when large data becomes big data, all that overhead becomes a huge burden. Big data needs a more flexible architecture than the standard RDBMS model. And when the price is right, Oracle wants to help the enterprise client satisfy that need. So, in October 2011, Oracle announced the Oracle Big Data Appliance. It's a pre-packaged, fully developed hardware-software solution that integrates truly fast and flexible big data solutions with their client's existing Oracle database. The Oracle Big Data Appliance is the keystone of Oracle's big data strategy. It comes with a rack of 18 Sun servers and a combination of Oracle-owned and open-source technology. Interestingly enough, you'll note that Oracle chose to partner with Cloudera. The Cloudera Hadoop and MapReduce framework is central to Oracle's big data storage strategy. So, for storage, there's 648 terabytes of hard disk drives using the Hadoop file system, but that's only part of the picture. The Big Data Appliance also comes with a bunch of tools. Some of the tools are designed to analyze that data in place, some to extract it and summarize it, and other tools to integrate that extracted data with the client's regular Oracle database. Oracle sees its users handling big data using the Big Data Appliance in 3 steps. First, design the application to write data directly into the Hadoop file system. Look on the far left. You see data gets streamed to the Big Data Appliance. On the right side, the same process is shown, but from a logical rather than a physical perspective. Note the HDFS living in the Big Data Appliance. Second, analyze your data in place using Oracle NoSQL Database and Hadoop MapReduce programs, including R. So far, this is all still happening inside the rack. Third, the tools of the Oracle data connectors, in conjunction with Hadoop MapReduce and the Oracle NoSQL Database, can put data into a format which can be read from within the standard Oracle RDBMS. Now, as far as the client's data warehouse is concerned, that data is a permanent part of the database, and various further analytics can be run against it. Base models of the Oracle Big Data Appliance start at a list price of $450,000, plus $54,000 per year maintenance, so I won't be doing my demo on that. But peering into the details of the Oracle Big Data Appliance, let's consider some of the tools individually. We've already spent a lot of time on the Hadoop stuff, and it's not actually Oracle technology. Then there is Oracle R, but we've already spent some time looking at R in the class. Another key component is the Oracle NoSQL Database, and since we didn't get the chance to learn about NoSQL databases in the class, I thought it would be a good opportunity to spend some time with it now. And it's available free online. The Oracle NoSQL Database is a key-value-based database introduced in 2011. Unlike the classic highly structured relational database, Oracle recommends NoSQL Database to acquire and store big data because it can handle data with a high variety and a simple back-end structure, a key and a content container holding the relevant data. The method of interacting with the data store is Java, conveniently enough, since Oracle owns Java. It also can interact directly with the Hadoop file system. Here's a quick synopsis of how the data is structured in the Oracle NoSQL Database. The best way to think about it is as a key-value store in which the data is replicated in 2 dimensions, both on multiple machines, which Oracle calls storage nodes, and on multiple replicas of the individual key values, which Oracle calls replica nodes. For each set of key values, there's a master node and a customizable number of replica nodes. Write operations go to the master node, which is responsible for passing the new values out to all replica nodes, while read operations can talk to any node. If a master node goes down for some reason, another node will automatically be promoted to master. There's no SQL interface, and the product does not support joins. It only supports insert, update, and delete operations of key-value pairs. The key-value structure in Oracle NoSQL is a little different than what we've worked with in MapReduce. The standard concept of a key-value pair is something like a string username as the key, and then the user's actual username as the value, or the string password as the key and a hashed password as the value. For the Oracle NoSQL key-value store, things are a little different. Oracle keys are always a string, but unlike your typical key, they have multiple parts. Oracle breaks the key into major parts and minor parts. Think of the key components as locations in a file system path. The major key in the Oracle system acts like a pointer. Often the major key is not directly related to the value at all. It acts more like a bucket in which many minor keys can reside. This leaves the minor key to be the descriptor of the value stored in the database. In this example, the major key is the actual name, not the string username as you might expect, but the actual user's name, Bob Smith, or Patricia Smith is another major key. Then, the minor key, which comes after the convention // is more like what we typically think of as a classical key. One difference, though, is that the minor key too can have multiple parts. So the minor key could actually have birth date, phone number, image, and user ID all as component parts of one single key. Of course, that might not be the best way to store your data, since you would have to retrieve a big image file every time you wanted to verify the user's password. So let's take a look at some simple things you can do with the Oracle NoSQL Database. I built a store to capture and handle data around our final class presentations. It can accept whatever you like: the students' names, the topics that will be presented, the grades of the students, their binary video presentations. Since all the data is stored in key-value format, it's nearly infinitely flexible. Remember this file? This is the one Professor Djurdjevic sent out with all the topics and the students who signed up for each topic. This was the starting point for my key-value store. The application I built can read in all of this data and store it as various keys and values. Each time the data is read in, if it finds the key there already, it will update the value stored in the database, and it will create new key-value pairs where the key is not in the store yet. We'll do things like find out if a topic is full yet, how many people are presenting for a given topic, list the students who will be presenting a topic, enter a URL for a student presentation, and retrieve the URL currently in the store for a student's presentation. Before we get to trying out the application, let's take a quick look at how it's constructed. As you can see, this is a Java package written with Eclipse. This is convenient since we've worked with Java and Eclipse before. The APIs that talk to the database are all provided in the Oracle installation package. You can see them here. They're the oracle.kv.kv store, and those come with the Oracle package. You'll see 4 classes in this project. We'll try each of them to give different examples of how to interact with the Oracle NoSQL database. So, let's see how it works. Okay, let's open up my virtual machine and try this out. So first, we'll start up the store using the default parameters. Now that's running, we can minimize it and open a second shell. It will continue running in the background. So to start with, let's take the data sent out by the professor, the spreadsheet that lists the topic, the students presenting, etc., and read all the data in it into various keys and values. You'll see in this command line I'm calling the class called import topic file. I'm giving it the path and file name of the file I want to read in. Well, that wasn't very exciting, but you can see it runs a lot faster than most of the MapReduce processes we've been working with, so that's nice. Now we have some data in there to play with. Let's say we want to know if a topic should be closed because it already has 5 students signed up. We'll run this process to find out. Note that I'm passing in a parameter called ID. That's the topic ID. Let's look at a few different topics. How about 37? You can see in each case it returns the name of the topic and how many students are presenting. We can try a third one. Let's try, here's one student. Okay, what if we want to know not how many people are presenting a topic, but get the list of all the students presenting it? Let's try this. You'll note that it's actually the same as the previous Java class. I just passed in another parameter to say I wanted the names. You'll note that the program sees you didn't enter parameters correctly and gives you the usage of all the parameters available. You'll see it says names has to take yes or no. So let's try again with names yes. Okay, and there's all the people presenting on topic 32. Next, let's try adding a whole new type of key value, one that was not in the original spreadsheet. We'll enter the URL of a student's presentation. As you can see, the name of this is setStudentURL. I'm passing in two parameters, the name of the student and the URL to set it to. I'll hit enter, and it returns some feedback saying that it's been set. Okay, last one. Let's query the database for the URL belonging to the student. In this case, we do two things. Change the class that I'm calling from set to get. And since I'm getting a URL, I don't need to pass one in. So we'll get rid of this and hit enter. And there it is. Pretty nifty. When you're done, you can close the Oracle NoSQL Database by going into the shell where you started it and hitting Control-C. So, clearly, only large organizations are going to invest in the full Big Data Appliance given the cost. But I hope that my presentation helped you see that there are parts of the toolset that anyone can use and appreciate. Lastly, I'd just like to say what a pleasant surprise it was to work with the NoSQL database. The installation was a breeze, and while I only installed it on one node, it's that easy to install on a multi-node architecture. You just repeat the process on each physical node, assign a master, and if they can all see each other, you're golden. Thank you all for your time.